Hello students, in this session
Let us solve a question on bending stresses. In the second part of this question, the condition is same. The statement is same that 600 Newton load is applied horizontally. And with this condition, we have already solved the first part of this question. In the second part of this question, we have to find the maximum principal stress in megapascal and the orientation of the corresponding principal planes in degrees, right? So we have to find out the maximum principal stress as well as the angle, the orientation at which this principal stress is acting. So let us solve the second part of this question.
in the second part of this question, it says that find out the maximum principal stress. When the principal stress is the plane, principal plane is a plane where there is no shear stress, right? And the value is either maximum or minimum. So value of maximum principal stress, sigma max, that is the normal stress. We generally denote by sigma 1, and the plane at which this theta p acts, right? So let us solve this question. For this, first find out the stress condition at point P. What is stress condition at point P? At point P, there is normal stress, which is sigma bending stress, which is tensile in nature, right? In y direction, this direction is y direction. And also there is shear stress, which is the maximum shear stress, right? Which we have already found out in the previous part of this question. So two stresses are there at this point P. One is normal stress and one is maximum shear stress, right? So if I draw the stress condition on this point P, there is bending stress, and because this is y direction, this direction is y direction, so this is sigma y. Suppose this is sigma y, which is sigma tensile bending stress, which is maximum, and also the shear stress condition is given. And what is the value of that shear stress? That is, we have already found out whatever is the value, that is tau. Say this is tau xy, right? So this is the stress condition of this point P. This is the stress condition of this point P, and we have to find out the maximum value of the principal stress and also the plane at which this principal stress acts, right? So what is the formula for principal stresses? Sigma 1, sigma 2 we know, that is maximum and minimum principal stresses, that is given by sigma x plus sigma y by 2 plus minus will be used for minimum stress, plus will be used for maximum stress, under the root sigma x minus sigma y by 2 whole square plus tau square. This is the maximum or minimum principal stresses, right? And here sigma x is 0, because there is no stress in x direction, right? So sigma x is 0. You can see here that sigma x is 0. So we can directly write that sigma 1, because we have to find out maximum, we will use the plus sign for that. So that will be given by sigma y by 2 plus under the root sigma y square by 4 plus tau xy square. This formula can be used. And in the previous question, we have already found out the tau max and sigma tb, which is sigma y here. So what was the value of tau max? I am writing here tau max, which came out to be, tau at point P we have written, tau at point P, the shear stress at point P, that came out to be, in the previous question that came out to be 56.6 megapascal, 56.6 megapascal. And the normal stress sigma p, or we are talking about sigma y because it in y direction. So sigma y came out to be sigma 67.9 megapascal. This we have already discussed in the previous part of this question. So we can put here the value of sigma y, and this is basically tau p is basically tau xy. So this tau p is basically nothing but the tau xy, right? So put the value of tau xy, which we have obtained, this value which is 56.6, and sigma y, which is this value, maximum value sigma tb, which is sigma y, that is 67.9, right? Put these values and got the maximum value of principal stress. So sigma y is 67.9 plus under the root sigma y is 67.9 square by 4 plus tau is 56.6, right? So out of these two maxima we will get further maximum value, that is the principal stress, right? So what is the value of sigma 1? Solve it and you will get the value of maximum principal stress. So this will come out to be, solving it we will get the value as 100 megapascal. 100 megapascal. So this is the answer of maximum principal stress. Next we have to find out the plane at which this theta p acts, right? And for that we know the formula. You should know the formula. You have to go to principal stress chapter and got the formula, and that was given by 2 tau xy upon sigma x minus sigma y. You should remember this formula. That was tan theta. Tan theta was given by this value. Tangent of theta principal stress was given by 2 tau xy upon sigma x minus sigma y, and we know 2 tau xy is 56.6 divided by sigma x is 0, this is sigma x, and sigma y is minus, that is 67.9. Solve it and get the value of theta p, the plane of, this is tan 2 theta p, I think, tan 2 theta p, right? Tan 2 theta p was 2 tau xy upon this value, right? So from here you can find out the theta p, the plane at which the maximum principal stress is obtained, right? Plane of maximum principal stress, right? Theta p can be obtained here, right? So theta p can be obtained. Solve it and get the value of theta p. You will get the value as minus 29.52, minus 29.52 degrees. So this is the another answer of this question, right? So one answer is the maximum principal stress, that is 100 megapascal, and the plane at which the maximum principal stress acts, that is minus 29.52 degrees. So the answer is, option is D. Option D is correct. So option D is correct, right?